In this video, I am going to explain the concept related to transistor cascode amplifier configuration. Transistor cascode amplifier configuration. It is a CE-CB. First point here is it consists of a CE stage followed by a CB stage directly coupled to each other and combines some of the features of both the amplifiers. This one is a CE stage. This one is a CB stage. Base, emitter, and collector. B1, C1, E1, E2, B2, and C2. It consists of a CE stage. This is the CE stage, followed by this one is a CB stage, directly coupled to each other. The output of the CE stage is connected to that input to that of CB stage. That means here direct coupled to each other and combines some of the features of both the amplifiers. Some of the features of both the amplifiers. CE has some advantages and disadvantages. CB has some advantages and disadvantages. With the help of that configuration, cascode amplifier configuration, have to combine some of the features of both the amplifiers. For high frequency applications, CB configuration has the most desirable characteristics. Because CB configuration, this is the CB configuration, the frequency response of that CB configuration is like that. Higher cutoff frequency compared to CE configuration. This one is lower cutoff frequency, higher cutoff frequency. For high frequency applications, CB configuration has the most desirable characteristics because there is no Miller capacitive effectance. Capacitive effect has there is no capacitive effect has been observed in CB configuration. That is the reason the CB configuration provides higher cutoff frequency. Higher cutoff frequency. CB configuration has a low input resistance. Low input resistance means almost acts as a short circuit to that CE configuration. Therefore, better isolation between output and input of this configuration. Another important configuration. The cascode configuration is designed to have the input impedance essentially that of CE amplifier. Input impedance. Input impedance. Input impedance that of input impedance that is moderate. Input impedance of that the cascode amplifier configuration is moderate. That means it is the top CE configuration. The top CE configuration. Fourth point is high voltage gain. The cascode amplifier configuration has a high voltage gain. High voltage gain. That of CB. That of CB configuration. High current gain. High current gain, that of CE. Good isolation between input and output. Good isolation. Good isolation between input and output. Input and output. Because since there is no direct coupling from output to input, the cascode improves input-output isolation, reducing a reverse transmission. As a result, the Miller effect is eliminated. Higher cutoff frequency range is increased so that bandwidth is much higher. Good isolation between input and output means higher bandwidth. Higher bandwidth. Second one is the seventh one is excellent frequency response. Excellent frequency response. Excellent frequency response is due to the top CB configuration. The top CB, higher output resistance, higher output resistance. It has a large bandwidth. It has large bandwidth with good isolation. With good isolation. With good isolation between input and output stages. Input and output stages. The merit of cascode amplifier is that it provides a higher voltage gain over a wide range of frequencies. The merit of cascode amplifier. The merit of cascode amplifier is that it provides a high voltage gain, over a wide range of frequencies. Wide range of frequencies. These are some important features of the cascode amplifier configuration. Generally, cascode amplifier configuration consists of CE stage followed by CB stage. These two stages are directly coupled to each other. CB stage has a low input resistance. Low input resistance means acts as short circuit. CB stage acts as short circuit at that CE stage. Better isolation between output and input of that configuration. That means it reduces the Miller capacitance effect. It provides high voltage gain, high bandwidth, and high input resistance. Excellent frequency response characteristics due to CB configuration and high output resistance. Disadvantages: due to their ability to provide good gain and large bandwidth characteristics of that cascode amplifier are commonly used in RF and other high frequency applications. These are the applications, important applications. Next, the cascode configuration can be more complicated than single transistor amplifiers. The cascode configuration means CB and CE and CB stages has more complicated than single stage transistor amplifiers. So careful biasing is needed to ensure proper isolation. Another disadvantage is greater complexity. Another disadvantage is increased more power consumption. These are the some disadvantages of cascode amplifier configuration. Next one, circuit diagram of that cascode amplifier configuration is biasing circuit. Q1, this is one Q1, RE, CE, RE, CE, direct coupled. This is a direct connection. This one is a CB stage. This one is a CE stage. VS, RS, CC1, coupling capacitor 1, R2, R3, R1, RC. This one is VCC. Here another capacitor is CC2, CC3. This one is out. This one is CB stage and the CE stage. Cascode amplifier configuration consists of two amplifier stages. First one is CE stage, second one is CB stage. CE stage is followed by it consists of a CE stage followed by CB stage, directly coupled to each other, directly coupled to each other, and combines some of the features of both the amplifiers. For AC analysis, set DC voltage is equal to 0. For AC analysis, for AC analysis, set DC voltage is equal to 0. Is equal to 0. That means VCC is equal to 0. Coupling capacitors and emitter bypass capacitor C are replaced with short circuit for AC analysis. CC1, CC2, CC3 and CE. These are the capacitors present in that cascode amplifier configuration are replaced with the short circuit. Are replaced with short circuit. Short circuit. Therefore, the simplified diagram is here VS in series with RS. The coupling capacitor CC1 is replaced with short circuit, and this one is RE. CE is replaced with short circuit. One more capacitance is there here, CC2. CC2 is replaced with short circuit. That means here, short circuit here, R2, R3, and VCC is equal to 0. R1, RC, VCC is equal to 0. CC3 is replaced with short circuit. CC3 is replaced with short circuit. This one is V0. This one is V0. This is transistor Q1 and transistor Q2. This one is transistor Q1 and this one is transistor Q2. The resistance R1 is connected between two grounds. Between this one is ground, this one is also ground. It has no effect. Therefore, R2 and R3. This is also ground here. The simplified diagram is like that. Vs in series with Rs. Here, any short circuit across Re is also short circuit. This one is R2 is connected between this point and ground, and R3 is connected between this point and ground. R2 and R3, these two are connected in parallel. R2 is connected between base and this ground. Therefore, R2 is connected between base of Q1 and ground. R3 is connected between base of Q1 and ground. This is the collector. This is the base one, C1, B1, E1. This one is a emitter. Emitter configuration. Base is this one is base 2. This one is E2. This one is C2. E2 is also connected to ground. E2, this one is a B1, E1, and C1. E2, B2, and C2. E2, B2, and C2. In between C2 and ground, in between C2 and ground, in between C2, this one is C2, and ground some RC resistance is there. RC resistance is there. This one is output is across RC. This is the simplified diagram. The transistor is replaced with universal CE amplifier configuration. Approximated the transistor is the transistors are replaced with approximated CE amplifier H parameter model. This one is a CE configuration. This one is CB configuration. Approximated H parameter model is like that here. Only two H parameters are involved. HIE. This one is base. This one is emitter. Base current is IB. This one is HFE, IB. HFE, IB. This one is a collector current. Collector current is IC. The collector current is IC. By using this model, this is the approximated CE amplifier H parameter model. These two transistors are Q1 and Q2 are replaced with this model. Q1, for the Q1 transistor, B1 is input, C1 is output, E1 is ground. B1 is input, B1 is input, C1 is output, E1 is ground. For CE, for CB configuration, E2 is input, E2 is input, E2 is input, and C2 is output, C2 is output, and B2 is the ground. This one is B2. In between B and E, HI is there. In between, this is the base terminal, and empty terminal is HI is there. This one is HIE, B2E, B1, E1, HI is there. The current flow through this one is IB1. For transistor, the base current is IB1. For B1 is connected to these two R2 parallel with R3, that is RB. B1 is connected to RB biasing resistance, that is equal to R2 parallel with R3. Here Vs in series with RS. Vs in series with RS. C1 is output terminal of the Q1 and E1 is the ground. In between C2E, some HFE IB is there. In between C1, E1 is HFE, HFE IB1 is present. Stage 1 is replaced with this approximated H parameter model. Coming to stage 2. Coming to stage 2, C2 to E2, C2 to E2, some HFE IB is there. C2 to E2, some the current direction is like that. HFE IB2, some C2 to E2, HFE IB2. For C2, RC is correct. RC in between C2 to B2, C2 to B2, RC resistance is there. This one is RC resistance. RC resistance. E2 to B2. Some E2 to B2 HI is there. B2E, B2 to E2, B2 to E2. Some HI is there. The current direction is from base to emitter. That means B2 E2. That is IB to IB2. IB2. One more connection is C1 and E2 are a direct connection here, direct coupling mechanism. C1 and E2 are directly coupled to each other. Therefore, C1 and E2 are directly coupled. This one is ground. Approximate, these two transistors are replaced with approximated H parameter model. RI1 input resistance RI1 without biasing resistors. RI1 dash RI1 dash. Here IC1 here IE2 I0 I0. This one is IB2. This one is IB2. IC2. This one is IC2. This one is IC2. Here output resistance is R0. Output resistance is R0. Input resistance is RI1 dash, RI1 dash. This is for stage 1, V input 1. For stage 1, V input 1. Here, stage 1, V01 output is 1. Stage 1 output V01. This one is across C2. This one is V0. This one is V0. First, you have to calculate the voltage gain AB. AB is equal to 2 stages are there. AB1 into AB2. AB1 into AB2. AB is the voltage gain is due to cascade connection of 2 stages. AB1 is the first stage voltage gain. AB2 is the second stage voltage gain. Need to calculate A1, AB1. AB1 is equal to output voltage V01 by input voltage VN1. Output voltage V01. V01 is equal to H of E this is the V01 across HIE IB2 V01. The current flow through this HIE is IB2. Therefore, V01 is equal to minus IB2 into HIE. Minus IB2 HIE by V in 1 is the current flow through this IB1 is the current flow through this HIE is IB1. The drop across this HIE is V in 1. V in 1 is equal to IB1 into HIE. IB1 is equal to HIE. Therefore, AB1 is equal to minus IB2 by IB1. Here plus V01. Our direction is opposite to IB2 current direction. Therefore, plus sign is here used. IB2 into HIE. Apply KVL. Therefore, V01 is equal to minus IB2 into HIE. This one. Minus IB2 by IB1. AB1 is equal to minus IB2 by here. IE2 is current enter into that node E2. IB2 is also enter. And IC2 or HB IB2 is also enter into that node E2. The algebraic sum of the currents and the node E2 is apply KCL at E2 at E2. Therefore, IE2 plus IB2, IE2 plus IB2 plus HFE IB2 plus HFE IB2 is equal to, here IE2 and IC1 are opposite directions. Therefore, IE2 is equal to minus IC1 minus IC1 is equal to minus of bring this outside, this in left right hand side, IB2 into 1 plus HFE. But IC1 is equal to IC1 is equal to HFE HFE IB1 minus HFE IB1 is equal to minus IB2 1 plus HFE. 1 plus HFE is approximately equal to HFE. This one and this one is cancelled, minus minus cancel. Therefore, IB1 is equal to IB2. AB1 is equal to, we know that AB1 is equal to minus IB2 by IB1 minus IB2 is IB1 minus IB1 by IB1, that is minus 1. That is minus 1. What about AB2? AB2 is equal to second stage. Consider this stage, output voltage by input voltage. Output voltage is V0, input voltage is V01. AB2 is equal to, AB2 is equal to output voltage V0 by input voltage V01. Input voltage V01. V0 is equal to I0 into the current flow through this RC is I0. V0 is equal to I0 into RC. Here I0 and IC2 are opposite directions. Therefore, V0 is equal to minus IC2 into RC minus IC2 into RC. IC2 is equal to HFE IB2. Both are currents minus HFE IB2 into RC. That is V0. We know that V01 is equal to minus HIE IB2. V01 is equal to, already determined here, V01 is equal to minus IB2 into HIE minus IB2 into HIE. Therefore, V0 is equal to minus HFE IB2 RC by V01 is minus IB2 HIE, minus minus cancel, IB2 cancel. Therefore, AB2 is equal to HFE RC by HIE. HFE into RC by HIE. High voltage gain due to common base configuration. Therefore, overall voltage gain is AB is equal to AB1 into AB2. AB1 is minus 1. AB2 is HFE RC by HIE. HFE RC by HIE. HFE into RC by HIE. Minus sign means 180 degrees phase shift between input and output signals. This is the voltage gain. Next, RI1 is HIE, RI1 dash, overall input resistance. Next parameter is overall input resistance. overall input resistance. Overall input resistance is Ri1 dash. Ri is equal to, first one is Ri1 is equal to Ri1 is equal to Hi. Ri1 is equal to Hi. Ri1 dash is Rb parallel with Ri1, Rb parallel with Hi, Rb is R2 parallel with R3 parallel with Hi. This is the Ri1 dash. Ri1 dash. Ri1 is equal to Hi. It means V in 1 by Ib1. Ri1. V in 1 by Ib1. That is Hi. Ri1 dash is this. Ri1 is comes in parallel with Rb. Therefore, Ri1 dash is Rb parallel with Ri1. Rb parallel with Ri1. Overall output resistance, that is R0 is Rc. Overall output resistance. Overall output resistance R0. It is this IC. This is the Ri1 dash. Next, overall current gain AIS. AIS. Calculate AIS. AIS means consider this figure. Output current I0 by input current. This one is IS. It will be IS. Output current I0 by input current IS. Here AI, AIS is very, very important. Output current I0 by input current IS. For this current, IC2 is the next. So next current is IC2. IC2 here and IC2. Next current is IC2 is completed. Next current is IE2. Numerator and denominator is multiplied with IE2. This one is IE2. Next current is IC1. Next current is IC1. Numerator and denominator is multiplied with IC1. Next current is IB1 and IB1 and IB1. Next current is IS. This is the AIS. Here I0, I0 and IC2 are opposite directions. Opposite directions. Therefore, I0 is equal to minus IC2. I0 is equal to, therefore AIS is equal to I0 is equal to I0 and IC2 are opposite directions. Minus IC2 by IC2. First one. IC2 is equal to HFE IB2. HFE IB2 by IE2. IE2 is equal to some of three currents are entering into that node. Therefore, IE2 is equal to minus of 1 plus HFE IB2. Minus of 1 plus HFE IB2. Minus of 1 plus HFE into IB2. This one is IB2. IE2 and IC1 are opposite directions. IE2 and IE2 is equal to minus IC1 by IC1. IC1 is equal to HFE. IC1 is equal to HFE IB1. HFE IB1 by IB1. HFE IB1 by IB1. Here IB1 is equal to the current flow through this HIE according to voltage division rule, current division, not voltage, current division rule. The total current applied to this circuit is RS into opposite resistance RB by RB plus HI. RB plus HI. Therefore, IB1 by IS is equal to last one. IB1 by IS is equal to RB by RB plus HI. RB plus HI. This is the overall current gain. Overall current gain of that cascode amplifier is minus IC2 by IC2 HFE IB2 by minus of 1 plus HFE IB2 IC2 is minus IE2 by IE2, that is minus 1. IC1 is equal to HFE IB1 by IB1. Last one is RB by RB plus HI. 1 plus HFE is approximately equal to HFE. Minus cancel. These two are cancelled. These two are cancelled. This one is these two are cancelled. IB1 is cancelled. RB is greater than HIE. This is also cancelled. Finally, AIS is equal to minus HFE minus HFE into RB by RB plus HIE. Current gain included with the source resistance.